Today we're going to be solving a system of equations, and we're going to start off with just reminding you of the process we learned for solving an equation and what that solution actually means. So you can see the example you have on your handout is 5x minus 1 equals 14. And if you go through the steps to solve that equation, you would get an answer of x equals 3. And I don't want to recap the steps for solving an equation because I know you know how to do that, but I just want to remind you of what that solution means. If x equals 3, that's the one value for x that satisfies the equation. And as you can see on the right-hand side, satisfying the equation means that it makes the equation true. And if you take the answer x equals 3 and consider substituting it into the equation, you might even be able to do this mentally. You would have 5 times 3, which is 15, and then 15 minus 1 is 14. So that's the value of x that makes the equation true. You might remember we learned to do checks when we learned to solve equations. I just want to remind you of how that works. If you're writing out your steps for checking an answer instead of just thinking about it, like I just described, what you would do is you would take your answer for x. Actually, first you would write down the equation. You would write the left side on the left side of the equation, of the chart rather, and the right side over there. So if you can imagine a little like dividing wall in the equation, what's on the left of that wall is on the left side of the chart, and what's on the right goes on the right side of the chart. If you take your answer for x equals 3 and substitute it in, anytime you see an x, which in this equation is just once, and then calculate it through, you can see that you get an answer 14 on both sides, which means that the point satisfies the equation. Now you can also have a system of equations. So if you take a look at that, a system of equations occurs when you have two or more equations. We're just going to deal with two. Our two equations that we're going to think about for today are y equals negative 3x plus 5 and y equals 1/3 x minus 5. If you're solving this system, similar to solving a regular equation where you found a value of x that satisfies the equation, if you're solving a system, you're finding the values of x and y because there's two variables, and they have to satisfy both equations. That means when you plug it into both equations are true. So I'm not going to go through the steps here of figuring out what those answers are. I'm just going to tell you that the answers are x equals 3 and y equals negative 4. Those values for x and y satisfy both equations. They work in both equations. And what we're going to do, though, is we're going to do a check for that point in both equations, because in order to satisfy the system, it has to work in both equations. So the first chart is for the first equation, y equals negative 3x plus 5. So if we put y on the left side, because that's on the left of the equal sign, and negative 3x plus 5 on the right. For the other equation, we have y on the left and 1/3 x minus 5 on the right. If we're checking our solution, what we're going to do is we're going to take the value for x of 3, and we're going to plug it into anywhere we see an x in the equation. And we're going to take the value of y equals negative 4, and we're going to substitute it in anywhere we see a y in the equation. So considering the first equation, if we substitute in y equals negative 4 and x equals 3, the point 3 negative 4, which is another way of talking about this point, that gives the x and y values because it's in coordinates. The point 3 negative 4 satisfies this equation if the equation is true. And if we calculate it, we can see negative 9 plus 5 is negative 4. That means that that point satisfies that equation. We're going to check the same point in the other equation. We're going to substitute in y equals negative 4 and x equals 3. 1/3 times 3 is just 1, which if you can just jump to that, that's great. If you need to show more steps, you can think of that as being 3 over 1. And then you have 3 over 3 minus 5. We'll extend that line a little bit. So 1 minus 5 is negative 4. And because both sides of that one are the same, that means that that point satisfies both equations. Now, you can verify that this works, but if you imagine trying to figure out these on your own, it would be kind of tricky, right? Because you've got these two equations, and there's lots of values of x and y you can pick. And like randomly landing on the ones that work in both equations wouldn't be that easy, which is why we have another method. It's called the graphical method of solving a system of equations. I'm just going to pause this here, and then in the next part of the video, I'll show you how to find this solution without being told what it is, how we can figure out that the solution to the system is x equals 3 and y equals 4.